Today we're going to do sections 12.2 and 12.4. We're going to be looking at prisms and cylinders, and specifically how to find the lateral area, surface area, and volume of those figures. So first we're going to start with what is a prism, and then what do we mean by lateral area and surface area. So a prism is a three-dimensional figure made up of two congruent polygons, and then those are called the bases, and then these lateral faces here and here. So in this particular prism right here in this picture, our two bases are regular hexagons. They're the only two that there are just two of them that are congruent to each other. Notice the rest of the faces are rectangles, and we call those the lateral faces. Where the lateral faces meet, we call the lateral edge. Where the lateral faces meet the bases, we call the base edges. This is a right prism because the top and the bottom are straight on top of each other, and the lateral edge is the same as the height of the prism, or the distance between the two bases. In an oblique prism, the bases are not on top of each other, and so the lateral edges are not the height. The height is still the distance straight down between the two bases. Notice that the lateral faces in this case are parallelograms. Lateral area is the area of those rectangle or parallelogram faces all added together. They do not include the area of the bases. Surface area is the area of all the faces of the polyhedron. All the lateral area plus the area of the two bases. Notice that the rectangle or parallelogram faces do not have to be congruent, so keep that in mind when you're doing the activity. When you open up the instructions, you're going to see 4 different prisms. These are right prisms, and when you classify a prism, you classify by the name of its base. For example, this base is a pentagon, so this is a pentagonal prism. These are all right prisms, so their lateral faces are rectangles, and the lateral edges are the height of the prism as well as the height of the lateral faces. I also would like you to draw a net. When you open up the web link and scroll down, you get to this activity here. This takes different types of prisms: triangular prism, rectangular prism, pentagonal prism, octagonal prism, and shows you a picture of the 3D that you can rotate on your own, and the net, which will open and close for you. Use this as a guide for filling out the nets for these 4 prisms. So I want you to classify each prism and draw the net. Then I want to have you use your pictures to try to come up with a formula for the lateral area, or the area of all the rectangle faces, in terms of height and perimeter. When I talk about perimeter of a 3D figure, I'm talking about the perimeter of the base. So in these cases, the perimeter of the pentagon, the hexagon, the square, or the triangle. Note that this is not a regular polygon, so keep that in mind when you're coming up with this formula. After you have a formula for the lateral area, I want you to come up with a formula for the surface area of the prisms. Remember that the surface area is the area of all the rectangles and the area of the two bases. or the area of all the faces of the prism. Okay, now that you've come up with those formulas for lateral area and surface area of prisms, we're going to talk about cylinders. Cylinders are very much like prisms in that they have two bases that are congruent to each other and can be right or oblique. If the bases are straight on top of each other, that height between the bases and this height here on the side are the same. However, if you have an oblique cylinder, that is not the case. This is the height of the cylinder, the distance between the two bases, and this is the length of a side. I want you to look at how cylinders are similar but different to prisms. Prisms have polygon bases. Cylinders have circle bases, and circles are not polygons. However, because they are so similar, we can use the formulas that you came up with for prisms to help us come up with those formulas for cylinders. Remember, we used perimeter for the lateral area of a prism and the height. It was the perimeter of the base. These bases are circles and don't have perimeters. So I want you to take the formula you got for the lateral area of prisms and adapt it to a cylinder with circle bases. I want you to also do the same thing for the surface area. Adapt the surface area formula that you have for prisms to cylinders by thinking about what those pieces would mean for circles. Okay, this last activity is going to be about volumes of prisms and cylinders. You're first going to figure out volumes of rectangular prism. Volume of a solid is the number of unit cubes in a solid. So when you make up your solid with unit cubes, if you have a rectangular prism, you can simply count the number of cubes, and that is your volume, or unit in units cubed. If you don't get a chance to pick up the unit cubes, we'll do this activity in class with the unit cubes, and you can figure that out. If you do know the formula for the volume of a rectangular prism, or the volume of a box, go ahead and see if you can make a conjecture for that formula, and then look at that formula and see if you can adapt that formula to prisms with bases other than rectangles.